Planet Saturn, presented to you by our home studies. About Saturn. Saturn is the sixth planet from the Sun and the second largest planet in our solar system. It is a gas giant, mostly made up of hydrogen and helium. Saturn has a diameter of about 116,460 kilometers, which is about 9.5 times that of Earth. It is also the least dense planet in our solar system, with only 1/8 of the average density of Earth. Saturn is known for its spectacular and complex ring system, which is made up of ice particles and rocky debris. The planet has at least 82 moons, including Titan, which is the second largest moon in our solar system. Temperature. The average temperature on Saturn is negative 178 Celsius or negative 288 Fahrenheit. The temperature variation on the surface of Saturn is due to the planet's internal processes, not the Sun. The upper layers of ammonia ice in the Saturn's atmosphere have temperatures ranging from negative 173 Celsius to negative 88 Celsius. The next layer contains water ice, with temperatures ranging from negative 88 Celsius to negative 3 Celsius. Temperature in the lower layers climb as high as 57 Celsius. Saturn radiates more than twice as much heat into space as it receives from the Sun. Most of the heat is caused by the gravitational compression from the planet, but scientists theorize that some of it may come from the friction created by helium sinking Saturn's atmosphere. Saturn's atmosphere is mostly composed of hydrogen 75% and helium 25%, with trace amounts of other substances like methane, ammonia, ethane, and acetylene. The atmosphere is much less interesting to look from a distance compared to Jupiter's, but enhanced color images allow us to study the bands across which run parallel to the equator, much like Jupiter's, indicating violent winds. Saturn is one of the windiest places in the solar system, and wind speeds have been clocked at a staggering 1,800 kilometers per hour at the equator. Occasionally, violent white storms break through the cloud layers, each one bigger than Earth. One of these was observed by the NASA/ESA Hubble Space Telescope in 1994. Smaller storms occur as darker spots. More about the atmosphere. There are three regions in Saturn's troposphere: the part of the atmosphere where weather occurs, where clouds of a particular kind or cloud decks are to be found. The location of the clouds is predicted based on the temperature at which vapor will condense into droplets. The point at which condensation occurs on a temperature profile where the clouds ought to be. The temperature in the troposphere ranges from about 130 Celsius in the negatives to about positive 80 Celsius. The top visible cloud deck, made of ammonia clouds, is found about 100 kilometers below the top of the troposphere or the tropopause, where the temperature is about negative 250 degrees Celsius. The second cloud deck, made of ammonium hydrosulfide clouds, is found at 170 kilometers below the tropopause, where the temperature is negative 70 Celsius. The lowest cloud deck, made of water clouds, is found at 130 kilometers below the tropopause, where the temperature is about 0 Celsius, or the freezing point of water. The rings of Saturn. Saturn's rings are made up of billions to trillions of particles ranging from grains to sand and to mountain-sized chunks. Composed NGS also draw in rocky meteorites as they travel through space. The rings are generally about 30 feet, 10 meters thick, and are almost completely composed of billions, if not trillions, of chunks of water ice, ranging in size from smaller than a grain of sand and to the size of mountains. The ring particles are made almost entirely of water ice, with a trace component of rocky material. The rings named alphabetically in the order of discovery. Thus, the main rings are farthest from the planet to the closest, A, B, C, E. A gap 2,920 miles wide, 4,700 kilometers, known as the Cassini division, separates rings A and B. As telescope technology has improved, it's fascinating to note that despite such low temperatures, Saturn has such a spectacular and complex ring system made up of ice particles and rocky debris. The planet has at least 82 moons, including Titan, which is the second largest moon in our solar system. The rings mystery. The origin of Saturn's rings is still a mystery, but scientists have proposed several theories. One suggests that the rings were formed by the debris of a moon that was shattered by a comet or asteroid impact. Another theory suggests that the rings were formed from the remnants of a moon that was torn apart by the gravity of Saturn. Yet another theory proposes that the rings were formed by the remnants of a comet that was captured by Saturn's gravity and disintegrated due to tidal forces. Data collected by NASA's Cassini spacecraft has shed some light on how Saturn's rings formed. The spacecraft discovered that the rings are made up of countless thousands of particles of dirty water ice ranging from microns to meters in size, from an icy moon that broke up eons ago, resulting in a violent collision. The scenario may be that a few 100 million years ago, a comet or asteroid slammed into an icy moon, breaking it into pieces. Saturn's titanic gravity then smoothed out those pieces into a flattened disk around the planet. Cassini data also suggests that Saturn's rings are just 150 to 300 million years old. Saturn missions. So far, Four spacecrafts have been sent to study Saturn. The first two were Pioneer 11 and the Voyagers 1 and 2, which conducted flybys of the planet in the 1970s and 80s. These missions provided us with the first high-resolution images of the planet and its rings and its moons. A most comprehensive look at Saturn came from NASA and the European Space Agency's Cassini-Huygens mission. Cassini was launched from Cape Canaveral, Florida in 1997 and took 7 years to reach Saturn, traveling 2 billion miles, which spent 13 years exploring Saturn and its moons. Cassini orbited Saturn from 2004 to 2017, circling the planet 294 times and teaching us that almost everything we knew about our ringed neighbor. The Huygens probe was released from Cassini and landed on Titan, Saturn's largest moon, in January 2005, 1 year after it started orbiting. NASA's Dragonfly mission is a helicopter drone that will explore Saturn's moon, Titan. The Cassini spacecraft spent more than a decade in the Saturn system, and what a mission it has been. Here are some of the most notable discoveries of the Cassini mission. Habitability on Saturn. Icy moons look more habitable than ever. Cassini revealed new levels of complexity in Saturn's moons. The probe found evidence of liquid water on some of the moons, spotted geysers and other geologic activity, and even found indications of prebiotic chemistry. Based on Cassini's findings, scientists think that the Saturn system is home to multiple moons that could be hospitable to life. One landing on Titan, the Huygens lander made it all the way down to the surface of Titan on January 14, 2005, which was exciting for the scientists in a few ways. First, researchers knew almost nothing about Titan's surface at the time. Pictures of Titan from both Voyager showed a blurry orange haze surrounding whatever was below. The Huygens got below that haze and found a moon with a solid surface dotted with lakes, oceans, and rivers made of hydrocarbons, mostly methane and ethane. Huygens also gave scientists a lot of information about Titan's environment, of the winds in the upper atmosphere to the dunes on the surface that form a strange material. Findings of Cassini continued. The age of the Saturn's rings. Cassini's data suggests that Saturn's rings are 150 to 300 million years old. The hexagon-shaped storm. Cassini discovered a hexagon-shaped storm on the North Pole that's about 20,000 miles, 30,000 kilometers wide. The plumes on the Enceladus. Cassini discovered plumes of water vapor and ice particles spewing from the Enceladus's outpole. Thank you for watching. Subscribe to our channel, Our Home Studies. Ring the bell. Keep watching and learn to find